We're moving on to chapter 2, which deals with associations between variables and how to interpret them. Now, first of all, variables, well, you've got the explanatory and the response variable. That's what we're talking about. Associations mean how they are connected. For instance, the case of the second-hand car, if you remember, as the car age increased, the value decreased. Well, that's an association. There's a connection, and one causes the other. And then there was the case of the age of a married man and the age of the married woman. And we decided that it was a bit bizarre that there should be any connection, and there probably isn't anyway. So sometimes there's an association, sometimes there isn't. We're going to look at some very vague ways of expressing the association at the beginning of this, and then as we move through chapter 2 and chapter 3, we'll get to more and more precise numerical, mathematical ways of describing an association, for the reasons that we might want to make predictions based on the association. We might want to do all sorts of analysis. That's what statisticians do. So that's what we're doing, interpreting associations between those variables. That is putting it into the words of correlation and causality. I will be explaining them, not necessarily today, but those are the mathematical terms. If two variables are related, there's a correlation between them. Have you used the word correlation ever? You know what I mean? Sort of. Two things are correlated, they're related, co-related. Causality, I've used that. I'm talking about cause and effect, so causality. And they are two different things, by the way, mathematically, correlation and causality. And because sometimes you can have a correlation without cause. Does the age of a car cause its value? Possibly not. Is the incidence of lung cancer caused by smoking? Possibly. So that's causality. There's a correlation in both of those things, but there's only causality in one of them. Anyway, that'll all become clear. I'll try and make that point again in the future. So in 2a, we're going to be looking at scatter plots and describing them. And I will be, in the next few moments, going through descriptions of scatter plots in terms of their direction, their form, and their strength. So these are three subheadings for this afternoon. Direction, form, and strength. You need to know which each of them means. Starting with direction. That's the car one again, isn't it? That's the age of a car and its value or price. There is a direction in the sense that they're going in a negative, the numbers are going in a negative direction, so they're going downhill from left to right, if you want to put it that way. So that's a negative direction. This is a positive direction. And presumably there's no direction to be seen on the third one. So that's first of the three things that you'll need to identify in 2a, looking at some scatter plots. All right, about that one, direction, positive or negative or nothing. Form, shape is another word for form. They follow more or less a straight line. These follow a curve. And again, this one doesn't. As far as you're concerned, they're either linear or non-linear or none. That is actually an upside-down parabola, isn't it? But it could be any. Usually there's some kind of a curve. It might be going that way, or it might be going that way, or it might be going, in this case. I can't think of any data immediately that would fit that pattern. But certainly you can have things going up in a curve or down in a curve. That would be non-linear. One on the big one is linear, so that's two things. This one is it positive or negative? Negative. Okay, so that's two things. You describe that as being negative linear. Strength. This gets a bit more dubious. Strength of an association means how much the dots are tightly forming that pattern. Now you can see that these are all doing it differently. I've written down strong, moderate, weak, or none, which more or less corresponds to this one, this one, this one, and this one. None is no problem. Strong is probably not a problem. You can also have another one which is perfect, which would be actually when the dots are in a complete straight line. But that would hardly be results of a survey. That would be like plotting a graph. So that's strong in that they're fairly tight together. Now this is very subjective. We try not to make you do anything that's ambiguous in a test. So this is difficult to tell. Can you see that they're both linear? No, well, are they linear? I suppose they are. They're both negative, but this one is more spread out than this one, so this would be a good example of a moderate, and that would be a good example of a weak. But don't get too upset about that. If you don't agree with what's in the answer of a question, then just discuss it with people and come to your own conclusions, because sometimes the textbook's a bit weird about that. All right? This one, linear, negative, moderate. So that's 3 things you can say about that one. There is another thing in the exercise 2A where you talk about outliers, because you will, as you did with outliers when you were doing IQR last year before, sometime, interquartile range, remember that? You looked at outliers. They are off the scale, as it were. You would not take this one or this one into account when you're deciding on the pattern. So if we had a dot up here, that would be an outlier. You've still got your linear pattern. This one breaks the rule, so you discount it. Overall, there's a linear pattern. That one is obviously outside your pattern, which goes like that. Looking at a scatter plot, strength, direction, form, are there any outliers? And that would be all there is to do with interpreting a scatter plot, so that's all there is in exercise 2A, which is only 2 questions. You won't